Hello there. I'm currently in the airport, so if there's any sounds in the background, that's why. And sometimes the announcer announces things. Anyways, I thought I'd do a little demo because we're required to do the demo. So, so this is AnyDesk. So I'm actually on my iPad right now, and I'm remoting into my desktop, which is in Potsdam. I'm actually in New Jersey right now. So if we can compile the code using this command that I put down here, gcc pthread o CS444 underscore 1. So this basically compiles it, and then this runs it. It took me a lot of time configuring Windows 10 to just work well with this, but basically I created the thing that the executable that can run with this. And if we run this, it will ask you for the number of rows for matrix 1, and let's just do like a 5 by 5 matrix, and a let's say a 1 by 5 matrix. So that cannot be multiplied because the rows and the columns basically don't match up for the first and the second matrix. It cannot be multiplied. That's a safety feature because it's not supposed to be able to multiply things that it cannot multiply. So let's do two 5 by 5 matrices. So over here, it's generating pseudo-random numbers, and it's basically multiplying both of the matrices together, and it's doing it in parallel. So you can actually have really, really huge matrices because every single thread has an individual calculation that it's doing. So basically, however many threads you have available allows you to go pretty crazy.
Airlines,
oh God.
Flight 711, Group
I'm so
1,
sorry about
traveling to Fort Lauderdale.
Yeah, there are limits to the amount of stuff you can do. The amount of memory you have in general. We can probably do two 10 by 10s. There we go, the result matrices over here. So that's a sort of demo, and
United
now I'll sort of
Airlines,
go through the
Flight
code.
711,
Basically,
2, traveling
we import
to Fort Lauderdale
some stuff here. We use the Pthreads library. This is C++, by the way. This is C++ file, Visual Studio Code. We define the number of threads that we're using. So we're using 4 threads in this instance. So actually, this is overridden later on, but basically, like, these are the default values that I just overrode later on. So basically, we have the matrices defined as like rows and columns, and the result is the rows and the columns, however many rows it has and however many columns it has. So like you can access like a different row and a different column to get a different value of the matrix, like one of the values. And the thread data structure basically stores a row and a column. And this is an integer value, so it's over the number line of just integers. And this is the main important thing. Well, actually, it's one of the main important things. But it basically, this calculates the dot product of a row and a column. So it makes that multi-threaded by essentially putting one of those like calculations inside of a thread. So it starts a pointer to a thread. And it basically stores the thread, like the row and the column, and then it starts with initial dot product, which is 0. It just assumes 0 because you're actually going to calculate that dot product. You're going to override that value, and so like you're going to multiply the row and the column, all the values in the row and column, and you're going to get your dot product. And so this is happening across however many threads you have available that you selected for. In this case, it would be 4 threads that sort of it sort of is defined with, and so like the main here, you choose the number of threads here, which is 4. Then we use the thread data to pass the data to the thread function over here. We define the thread count again just to keep track of the number of threads, which the number of threads is also defined there. This is a random number generator seed. So that helps you get like the random numbers that you're putting in these matrices. So it prompts the user, enter the number of rows for matrix 1. So the number of rows and columns for matrix 1 must equal the number, basically the number of columns in matrix 1, which is like, you know, the amount of like pillars, has to be equal to the number of rows in matrix 2. And if it isn't, then it's gonna scream. Basically, like, if the columns of 1 do not equal the amount of rows in 2, it will give you this error and it'll return 0. It'll basically not return anything. So, you know, you put in those values, and as you saw in the demo, it generates what you're looking for. So this is where we actually fill the matrices with random numbers. So it's going through every row and column of the user-defined rows and columns, and it's filling up each of the values with like a random integer value between like 0 and 9. So basically, you know, once you multiply two matrices together, you'll get some kind of some other integers in the resulting matrix. The matrix is printed out basically like iteratively. You print out the first element of the first row, then the second element of the first row, and so on and so forth. Same thing with the other matrix. So this is a main loop where you basically keep creating threads and basically using the dot product function on them. So like this like pthread create sort of like function is doing a lot of this activity, and you keep iterating through the threads, the amount of threads that you have with this. So you can join the threads basically all together. Eventually, like the threads have to finish essentially like before printing the result matrix, so this like joins all the threads. So threads have to finish first before you print it, because if you don't wait to print them, then they'll have like basically like 0 values, so you don't want that. So then you print out that final matrix, and then you exit the pthread like program. Then I put some examples here of like what output you might expect if you give like a 4x4 matrix and you multiply them together. So that's sort of the shebang. I hope you can hear most of this, because unfortunately I have a unlucky scenario where I am actually recording this video, but it should be on YouTube pretty soon. This specific thing I just want to point out, I had to put it in there because the main function was not returning a value, because like there's this random diagnostic thing. I think it has to do with versions, but anyways, I figured out that you need to do this. I put the description of what we need to do over here. I guess I'll put my Clarkson email as well right there. This is I wrote it a bit ago, but I'll just put that there, and yeah, I'll put the repo link in here, and I'll also put the YouTube link. So yeah, if you guys have any questions or comments or whatever, you know, just put them in the comment section. And this was very interesting, and this is sort of what happens under the hood of a GPU. It's always doing parallel computations, and they're very simple computations, but they're very important. Yeah, so I don't know if this is 10 minutes, but I think I went over.
United Airlines
Oh God, no.
Flight
All right, goodbye guys. Have a good day.